Hi guys, this is a calculus video, video 6-1, first video of unit 6. And on the calendar in the front, it does say to watch this video on the weekend, but I forgot to give period 3 their packets on Friday. So this is the only date I will change, I promise, but this is to be watched Monday. And you can watch it during class because I'm not going to give partner problems. So, but there will be 2 videos for Monday. There'll be 6-1 and 6-2. Okay, so I'll read these things in a moment, but let's just look at the problem. It says this. It says find the area bounded by the functions f of x equals 10 over x and g of x equals that in the first quadrant. Okay, so when you're doing a problem like this, where you're finding an area that is bounded by some functions, the very first thing that you want to do, if it's on a section where you can use a graphing calculator, you want to graph the functions and see what your region looks like. If it's a section where you can't use a graphing calculator, then they'll probably be easy functions to graph. Like, you know, just the standard functions like parabolas, cubics, absolute value, things like that. All right, so so the first function is 10 divided by x, and the second function is negative 1/2 x squared plus 5.5x minus 4. And then I'm going to graph those. Okay, so there's the 10 over x function, and then there's the parabola, so that's g of x. And the area bounded by these in the first quadrant is this part right here. So bounded by them means like enclosed by them. And sometimes if you even want to like adjust your window a little bit, like I'll move the y max up to 15. And then you could see it, we'll be able to see the top of the parabola better. Okay, so right there. And I'll even move the x's out a little bit more so I can see past there. So window, I'll do x max 15. Okay. Now, sometimes, because I've done this so much, it's clear to me that this thing here, that's the region that they're talking about, that I'm going to try to find the area of. But if it's not clear to you, the easiest thing I think to do is find the intersection points and then, you know, look for the intersection points. And so those are kind of like the vertices of your region. And then maybe after finding those intersection points, so you know these are the vertices of your region, and then this would be the inside of the region. Okay, so let's draw this on our paper. Okay, so we only really care about the first quadrant, so that's like what the 10 over x looks like. And then the parabola looked something like that. Okay, so whenever you're doing these problems, find the intersection points, okay, and then you'll see why in just a moment. And the way that you could do that on your calculator, if you want to do it algebraically, you could just like set these equations equal to each other and then solve from there. But on your calculator, the way you do it is you go to Calc and then intersect. And then you move kind of close to the intersection point that you're looking for, and your calculator will ask you, is this the first curve? Yes. Is that the second curve? Yes. And then you hit it a third time for it to get the point for you. So that intersection point is 2, 5. Okay, so right there, 2, 5. So this process, you want to draw the region, you want to find the intersection points, and then we'll have other steps. Intersect. Okay, so I'm moving closer to there. First curve, second curve, guess. 10, 1. Okay, so 10, 1. Alrighty, so those are like the vertices of my region, and then that's the region. I'm going to try to find the area of that. Now, here's the thing, guys. Let's go back up here. Vertical line test for a region and horizontal line test for a region. There's one of 2 formulas that you're going to use when you're finding the area bounded by 2 or more curves. And to decide which of these 2 formulas you use, If your region passes the vertical line test, you would use this formula. If it passes the horizontal line test, you'd use this one. It could pass both, and then you would have your choice. But the vertical line test for a region, it'll pass the vertical line test if every vertical line through the region intersects the graph of each function only once. If your region passes this test, then its area is going to be given by this, and I'll explain it further in a moment. Horizontal line test is the same except horizontal instead of vertical. Every horizontal line through the region intersects the graph of each function only once. If your region passes this test, then its area is given by this formula. Okay, and so let's see what it passes. I'm going to use a transparency. That's the easiest way. Okay, so vertical line test. So I have to consider like any vertical line passing through this region. So like this vertical line, it hits the top function only once, and it hits the bottom function only once. And if I move it, no matter where I move my vertical line, it's hitting the top function once and the bottom function just once. So we are passing the vertical line test, which means that we can use this formula to find the area between the curves. Now, horizontal line test, notice it is not passing that. This horizontal line test is hitting g of x twice. It's still hitting g of x twice. It's still hitting g of x twice. Like this horizontal line, it hits each graph only once, but it doesn't matter. It has to be every, I think I called it vertical. It has to be every horizontal line that intersects each graph only once. So we are passing the vertical line test, so we're going to use this formula. So let's write it down. It goes like this. The integral from x, oopsie, you can't see. The integral from x equals a all the way up to b, and then top function minus bottom function dx, okay? So if it passes the vertical line test, your integral will be in terms of x. Horizontal line test, we'd have to change things to y's. So then we're just going to use this formula. So you ask yourself, what is the lowest x value for points in this region? It is 2. Okay, this region starts at the x value 2. So my interval will start at 2. It'll end at the x value 10. And then you've got to do the top function minus the bottom function. So sometimes it helps if you do a vertical line, okay? The vertical line intersects this function. So what is this function? That would be the top function. That's g of x. So it's going to be g of x, which is negative 1/2 x squared plus 5.5x minus 4. And then the bottom function would be this one that I'm intersecting down here. That's the other one, minus 10 over x. So top minus bottom dx. And then you can just plug it into your calculator using Math 9. Okay, so Math 9. And then from 2 to 10, negative 1/2 x squared plus 5.5x minus 4. Oopsie, I wrote 10 over 10 on my paper. You probably caught that. It should be, okay, so minus, did I do divided by? I did. Minus 10 over x dx. Okay, so I believe that is correct, unless I typed something in wrong. Okay, so right there, let me see if I can get a fraction. Oh yeah, it's messy though. Alrighty, so this is 50.5723. Okay, that's the area of that region that is bounded by those curves. Okay, now I don't think we have a second example. No, we don't. But let's write down the steps that we did, okay, in case it helps. So 1, when you're doing a problem like this, first you graph the region. 2, you find the intersection points, okay, so like the vertices of the region. 3, you do line tests. Do line tests to choose formula. And then step 4, you use the formula. Okay, so pretty straightforward. Okay, so there's that, guys. And there is a homework problem. It's on page 3 and it's number 2. And hopefully right now you're watching this in class and then you'll do that problem right now. And I will talk to you later. Bye-bye.